not only do you want to narrow down the problem to the solution, you want to narrow down the entire process. I mean, who says that you have to like spend a good 10 minutes, or I don't know how much time you have to spend of like inputting text, effort, and troubleshooting to find a solution? What if you
Right.
can make the entire process automatic?
Hmm.
As in, like, can you, what if, like, let's say I'm a student, well, I am a student, but can I,
Yeah.
as a student, spend my 2 years in Marianopolis without ever submitting a form or a complaint, but at the same time have a computer program that tells the administration all of the concerns and problems that I have and solve things without even pressing a button
Wait,
ever in 2 years?
how do you think that would work?
There are a few ways where it can work. So uh, I'd say there's two approaches. One approach is just creating a form for students to ask questions. So
Hmm.
if there's a question students have, they type in a couple of sentences. Say for instance, one concern is right now is if my parents are at risk to the coronavirus,
Right.
can I avoid in-campus classes?
Hmm.
So instead of like making it super descriptive, going through like some complicated decision tree, you just ask that question. The
Right.
question gets kind of like its own bubble, you can say,
Sure.
and that bubble kind of floats around in this really big database. That bubble will be like, okay, there's this topic, and if there are other similar bubbles that pop up, let's say somebody asks, for instance, can I stay home for exams, which is a very similar question.
Right.
Those two bubbles can actually merge and create an even larger bubble. So in this way, like you're
Um,
really like you're grouping together really similar questions in this really big bubble, and this bubble kind of self-organizes itself. You're merging similar questions together in a really
right. Right.
concise and clear way. And because everything is so merged together, you're saving time and effort for both students, student government, and the administration in terms of identifying problems, answering it, getting back to you. And once you merge all of these things together in an automatic way, you're basically saving a lot of time troubleshooting, going through all the specifics. So you just input questions, and the output is basically a simple streamlined question.
Hmm.
And you can even go one step further and streamline those questions with streamlined answers as well.
So is it gonna be like a detection of keywords between answers and stuff?
So there are a few ways to go about it. So you can say one way is to divide like a sentence grammatically into different sections, like the
Right.
subject or predicate, subject, predicate. If like the overall keywords in those groups
Hmm.
are similar enough to keywords in other groups in terms of similarity, then you can kind of group it together.
What kind of technologies are you guys using to develop this?
Well, we're currently still in the process of developing these models we call NLP models,
Right.
so natural language processing.
Hmm.
Um, so there are a few ways. One, the easiest way would really just to be to match keywords that are like really similar. If the word school at home,
Work from
like
home.
work
Yeah.
from home, we can just merge them together. Another way is using what we call word to vector models. So it's scary sounding, but it's insanely interesting.
Word to vector.
Word to vector.
That sounds some fourth dimension. Yeah, absolutely.
It's actually, if you want to be specific, it's multidimensional. It's
All right. Well, there you go.
you have a lot of dimensions. So basically, how word to vector works is,
Uh-huh.
so at one point, some researchers wanted to like kind of find a numerical representation of words. So let's say you have the word ice
Sure.
and you have the word uh, snow. So ice and snow would probably be more related to each other than
Um,
ice and fire.
I see.
So the question of how they do this is they went onto Wikipedia, they scraped all of the Wikipedia pages that were present at the time, and using some sort of machine learning models, where from memory they just inputted all the raw data, and they let the machine learning model itself try to make links between different words.
Now, when was this?
This was done in the last, I believe, maybe 5, 6 years or so.
Okay, that's
So the fir-
reasonable.
so the first model is Word to Vec, and there's an improved one called
The glove.
Glove model. So, I mean, I still have to I have to do a bit of research to
Hmm.
give you guys a specific answer of how Glove and Word to Vec actually work. But the main idea is that once the model runs, each word is assigned to a vector. So basically, you can say a point and an arrow.
In a two-dimensional
Oh no, like
plane, or? Oh, right.
multi-dimensional.
Yeah, that's what I was
I
wondering,
mean,
because
multi-dimensional. I mean, I think some of Glove's vectors had up to like 200 dimensions, if I'm not mistaken.
what does that mean, having like these dimensions?
So dimensions really are arbitrary. Like I have to do like a bit of research to understand how Glove works.
Just basically like
Yeah,
factors you have to take into account. Yeah, okay. So you
basically.
have.
Yeah. I mean, if this makes sense to you, like to my understanding, uh, so Glove, you have like the original input, which is like each text that gets numerized, and there's like
Hmm.
an output. The input and output are highly related. But
Right.
then you have like but then like it's kind of like you have the input and output, and you have the middle layer. The
Hmm.
middle layer and the middle layer kind of connects the two. I mean, the middle layer is the result of the input being transformed to some
Okay.
intermediary structure, and the intermediary structure then becomes the output structure. So the intermediary structure just happens to contain 200 such values.
Right.
And if you take these values, you can easily take these values and assign it to a certain point in space. So if you have two words that are very close together, let's say ice and snow, if they're very close
Sure.
together, it means that they're highly similar. And we can apply the same logic to any sentence. So you take any sentence, and if the average value of every word
Right.
compared to the average value of every word in another sentence are very, very close to each other, it means these two sentences are very close in meaning, even if the actual text is somewhat different.